Let's have a look at how we can generate circular motion using sine and cosine. We have used sine before. We know the sine is a function that returns a number between -1 and 1. It takes one parameter, which is the angle, and cosine we haven't seen yet. And we don't know even what really sine is. We haven't looked at it. But we will see it a little bit in this episode. And this episode is going to be a little bit different. I'm going to first make a program that generates some graphics, and then we're going to have a look at how it really works. So I have here this simple setup that's just setting the background color, the color mode, the size of the screen, smooth mode, and the width of the lines are 3 pixels. And I'm going to have here a variable, which is an angle, float a equals 0, and a second angle, float b equals 0 also. And we are going to increase those two angles here inside the draw function. I'm going to do a equals a plus 0,03 and b equals b plus 0,05, for example. So now we have a program that simply is increasing two variables over time, one faster than the other. And I'm also going to have a variable for the colors. So I'm going to say here float co equals 0, and I'm going to be increasing that too. I'm going to say co is co plus 1. And if the color goes over 100, because I have said here that in the color mode we are using values up to 100. So if we go out of that range, then let's start again from 0. If it's greater than 100, then make it 0. Okay, until now we don't have any drawing here. So I want to draw some lines here. I'm going to declare 4 variables. x0, y0, x1, and y1. And then I will draw a line between x0, y0 to x1, y1. So I have to define these 4 variables. What are these? What value do they contain? I'm going to use a map in each case. And I will be mapping a sine function, sine of a, which we know returns numbers between -1 and 1. And let's say here that we get values between 20 and 480. I want to leave a margin of 20 pixels around the screen, so that's why I'm not saying here the width. Or I could say here 20 and width -20. I will use the same idea for the y value, but instead of sine, I'm going to use cosine of a, same angle, -1 and 1, and 20 and height -20. Very similar. I'm just changing the height and width here, and in one I'm using sine and in the other I'm using cosine. And same thing for the other 2 variables, but I am going to use the angle b instead of a. So this is going to be map sine b -1, 1, 20 with -20. And again here the same thing, map cosine of b -1, 1, 20 and height -20. So let's run this program and see what we get here. Okay, it's nice, but the colors are missing. What happened to the colors? Okay, I forgot to add here a stroke. So stroke, I will say here co, that's the variable which I'm increasing, where I'm storing the current hue. And I'm going to say the saturation is 80, the brightness is 80, and I'm going to use here alpha value. I want it to have some transparency. What do we get now? Okay, this looks much nicer. So we're getting this interesting pattern, and the pattern changes a little bit depending on how or which kind of numbers we enter here. If we enter here 0.2 and in the other 0.5, let's see, what do we get now? Okay, so it looks beautiful. Now you may be wondering, how is this happening, or why are we getting this image? So we should have a look at what is this sine and cosine. And for that, I have this little program here where we can simulate some numbers. Okay, this is a circle here. We are interested in the black point, which I can make rotate around here. And the sine is the length of the green line. So the sine is the distance between the black point and the axis here, the x-axis. So you can see here the length of the green line, and it's here also indicated. The length is now 0.68 because the circle has a radius of 1. That means that the length of this blue line is always 1. And in that case, you can see that the length of the green line is 0.69. The cosine is the length from the point to the y-axis. So you can see it here in orange, and it's here 0.72. When we call sine and cosine, you can see it back here, we are sending an angle. What is this angle? So the angle refers to how much are we rotating around this center. And an angle of 0 is right here. We have assumed that 0 means that we are here on the right side of this circle. In that case, the distance from the point to the axis is 0. So that's why the sine of 0 is 0. And we can type this here, a small program, print sine 0, and see what we get, and we get 0. So let's study what happens as this point rotates. You can see that as the point goes up, the length of this green line is increasing. You can see it back here. Now it's 0.47, and it increases 60, 70, 80, 90. When it's on the top, the length is 1. But look at what happened to the other line. The other line disappeared. As we go up, the length of the other line decreases until it's 0. So it's like sine and cosine are cousins living in different parts of the planet. When one is awake, the other is asleep. So you can see what happens to each of sine and cosine as this point rotates. Let's concentrate on the sine, the green line. You can see as I rotate, it's increasing. Now it decreases again and gets near 0. Now it's getting down, it's increasing again. Now it's -1 because it's on the bottom side. And now it approaches 0 again and increases 1. That's why we're getting numbers between 1 and -1. So it's when you're up here, you get 1, 0, -1, 0. And the same thing is happening with the cosine, the orange line, but with a different rhythm. So cosine starts being 1 here. You can see it, here's 1. And as we go up, the cosine goes to 0. Now -1, 0, +1. So what we are using here in our program, we are using sine and cosine and the same angle, in both cases. So this way we can find out the position of this point. It's a nice way to have objects moving in a circle. We will not go in this episode into what the angles mean. Why are we having these strange numbers? Why up is 1.57, or why is in this side 3.14, or down here is 471, and a complete turn is 6.28. We will study these numbers in another way. Maybe you are more familiar with these other numbers like degrees. This is a 90-degree angle, which is 1.57 radians or p radians, which is half p. I don't want to confuse you now with these numbers, but I just wanted to show you that you can use sine and cosine together to generate circular motions. So let's go back here to our program and see what's going on actually. I'm going to replace this line with some points. So I'm going to draw the 2 points. I'm going to have here point x0, y0 and point x1, y1. I'm going to say that the points are black. And before drawing this line, I'm going to erase the screen saying background 100. Remember that now we are working with numbers up to 100. So here are 2 points. And what's happening, you have seen down here, we have 2 angles. One is going much faster than the other. So you can see one point is moving or both points are moving around the circle, but one is really running and it's catching now the other, and it's running much faster, and now it catches the first point again. And what we are doing in our program are drawing lines between these 2 points. So you can see what happens. I'm going to activate again our line, and I'm going to deactivate our spinning points here. So maybe now you have a better idea of what's going on. You can see the 2 points are spinning there around the circle, and it's drawing colorful lines between the 2 points. So then we get these beautiful patterns. So try playing with these numbers and see what kind of graphics do you get.